All right, so in this video, I'm going to again turn my equation into a graph, and we're going to do it using the grade 9 method of plugging our x values into our formula to solve for what y is when x is a given value. Now I am going to demonstrate and talk a little bit about the grade 10 application of using both slope and what we call the y-intercept. So we're going to talk about that a little bit in this video. Now I do want to give credit. I'm using Desmos, which is a free online calculator, graphing calculator. So Desmos, thank you so much. I'm not making any money off of this, so please don't come after me for using your stuff. It's just to show my students. So you can see I've got my first equation here. We've got y is equal to 3x minus 2. And from the last video I said we need to pick values that we're going to put in for x. We want to pick 2 negatives, 2 positives, and 0 as well. So again, because I want to pick smart values, I'm going to go in order. So I'm going to go -2, -1, 0, 1, and 2. I want to keep them nice and sequential because when I have a nice sequence, I'll be able to see the pattern. Now, I also, when I include 0, that gives me something very helpful because when I put in that value of 0 for x, so if I was to put in a 0 here instead of x, you see that I get y is equal to -2, and that's because when we substitute in 0 here, that gives us our what we call the y-intercept, because it's when x is 0, which really is just along this y-axis, it gives us what the y value is going to be. And it turns out that the y-intercept always is this constant part of our equation, the thing that's not attached to the variable. So this -2 here is the only thing that's left over. So when x is 0, y is -2, so we get that one simply there. If I was to then change x to 1, and I go 3 times 1, which now gives me 3, and 3 minus the 2 afterwards gives us our value y is equal to 1, so I can substitute that in there. Now again, you might notice as x went up by 1, we went from 0 to 1. Y went up by 3 because we went from -2 to 1. So when I put in my next value, it's gone up by 3 again. So I increased from x being 1, I increased the x by 1 more to make it 2, and my y value goes from being 1, which we can see in the corner. When I type in 2, y is now 4. And we actually could have guessed this because when we look here, we see that the coefficient for x is 3. Now remember, that is what we would call, and we're going to do this a lot more in grade 10, that's what we call the slope. And our slope, as a reminder, slope is our rise over run. And another way of thinking of rise over run is we call it, it's our change in x divided by our change in y. Let's see if I can add another note here. So it's the change in change in y, and it's divided by the change in x is the slope, rise over run. So how much are we going up or down divided by how much we are moving left or right. Okay, so that value of 3, if we were to get that as a fraction, it would be 3 over 1. And that means that we are going up 3 every time we move 1 to the right. And that's exactly what our table of value tells us. As we went from 0 to 1, we moved right 1, so we had to at the same time move up 3, because that's what the change in y was. So that's why we went from -2 to +1, and then from +1 to +4. As x changes by 1, y changes by 3 because of the slope that we have, which is always the change in our y direction divided by the change in our x direction. And so I can reverse this in my table of values here. If I go down 1 for x, or in left 1 for x, I have to do the opposite. So instead of going up 3 for y, I would go down 3. So I get my next value is -5, and then -8. And hopefully you've been noticing as I've been typing in those points, they've showed up in orange on my graph. I'm just going to drag it so I can see things a little bit more clearly. On my previous video, I was not using a ruler, so my points weren't very accurate, but now that I'm using the computer, I can see that these points lie in a nice straight line. And if I wanted to connect them with my line, I'm just going to click over here, select it, and you can see now the points are connected and they all fall on that same line. Okay, let's try another one. This one, we've got y is equal to negative 4x plus 3. So again, I'm going to start off with those points, negative 2, negative 1, 0, 1, and 2. And very quickly, I should be able to see, well, if x is 0, the negative 4x part, that's just going to become 0. The only thing I should have left is this value of positive 3. So when x is 0, y is 3, because that is my y-intercept. Now, my slope here is telling me, again, it's change in y divided by change in x. Okay, when I look at the slope, my slope here is negative 4, and that would be negative 4 over 1. So what this means is as I move to the right one space, I'm going to now move down 4 because we include that negative with the 4. All right, see how the negative is sitting here in front? So as we move to the right 1, we're going to go down by 4. So I'm going to substitute my next thing in here. I've moved to the right 1 because I've gone from 0 to 1, and now I'm going to move down 4. So negative 3 move down 4 places is going to take us to negative 1. Okay, and you could see if I was to oops, let's see, if I was to change this here so that I can drag my points. If I have my point here where it was at 0 and 3, I'm going to move 1 to the right and then move 4 down. So there's 1, 2, 3, 4 down. Okay, so that's how I move from one to the other, is we move 1 right and 4 down. If I do that again, I move 1 right again. My next point now, if I move down 4 more from negative 1, is going to be at negative 5. And a key thing here is you should notice that as you're filling in all these points, you should have a straight line. If something looks like it's not fitting on a straight line with everything else, you've substituted something incorrectly. Now again, just to double check, I can put these into the calculator. If I go negative 4 times 1, that gives me negative 4, plus 3 more, and I get negative 1. That's what y is. You can see that value down here in the bottom corner. If I change x to be 2, negative 4 times 2 is negative 8, plus the 3 gives me now negative 5, and that's exactly what we have in our table of values. If I go the other way, negative 4 times negative 1 is positive 4, plus 3 extra is 7. And if we go negative 2, negative 4 times negative 2 is positive 8, plus 3 takes us to 11. Okay, and so I'm going to just bring in the equation, or bring in that line, and you can see we actually have all 5 of our points fit on that line, so we've graphed it correctly. I'm just going to do a couple with fractions here to just show you how it changes. So as a reminder, we are looking at our slope is our change in y divided by change in x. So looking at this slope here, I have 2/3. It's 2 over 3. This means as I move to the right 3, I move up 2. So this one has a very different slope. And we talked about picking smart values for x. So I know I want to pick 0. Oh, hold on. I know I want to pick 0 for x. And when I do that, I normally would go 1 and 2 afterwards. But I'm going to pick a smart value here because I want something that's going to be easy to work with, because I don't want to try and graph fractions. So if I've got 0, the next number I'm going to pick is the denominator, which is 3. So I'm going to choose 0 and then 3 and then 6. That's going to be my pattern. So I'll finish that off by going negative 3 and negative 6 on the negative side. And again, the reason I want to do that is because my slope is telling me as I move 3 to the right, I know what is happening in my y direction. I'm going to go up 2. So that's the whole reason I want to use movement of 3 as opposed to how far when I move just 1 for x. It doesn't work as nicely. Now again, when I put in 0, just like before, this whole thing here is going to be 0. 2/3 times 0 is 0, and we have 0 minus 1. So our y-intercept is -1. Now, as we move right 3, so as we move from 0 to 3, we've gone right 3, we are going to move 2 up in the positive direction for y. So since we're starting at -1, as I move 3 to the right, so 1, 2, 3 to the right, I'm now going to move up 2. So 1, 2. My new point is going to be at 3, and +1 is my next one. And if we type that in here, 2/3 times 3, remember the 3's here will cross reduce, they will cancel, and we're left with 2 minus 1, which is just 1. So that is our y value there. Same pattern as we move 3 to the right, so we go from 3 to 6. We're going to go up 2, so we're going to go from 1 to 3. And this is how we track our movement. If I go the other way, if I go now 3 to the left for x, 1, 2, 3 to the left, then I'm going to move down 2. I just do the opposite. So I go from -1 down to -3. And then I would go down to -5. And so you can see I've got this nice consistent pattern. X is always going up by 3, y is always going up by 2. And I can find this set of points where x is 0. I can find that very quickly because that's my y-intercept, or the constant in my equation. Okay, just double check, throw the graph on there. Yeah, all the lines all go through the points that we had. So there we go. We've got that one graphed correctly. Okay. One more for you to try. Maybe you can pause this video for yourself. Try filling it in and see if your graph would match what I have here. So again, if we're looking at our slope here is -1/4. So that's a -1, and maybe I'll put it in brackets so it's easier to see. -1/4. This means a movement of 4 to the right, because we go left or right in the denominator. The 4 is positive, so it's 4 spaces right is a movement of 1 down for y. Picking our smart values, I want to start with 0, and then I want my next number to be 4, my next number to be 8. And then I also need the same thing. Here we go. I need the same thing, but I need those values to be in the negative positions as well. So I need -8 and -4. Okay, those would be my values I would start with. When x is 0, this part here, -1/4 times 0 is 0, so I'm left with just the +2. I'm left with that y-intercept. And then again, as we move 4 to the right, we go down 1, right? The denominator is our change in x, numerator is our change in y. So as we move 4 to the right, we go down 1. So I've gone from 0 to 4, we've moved 4 right, we need to go down 1. We were at 2, we'll now go to 1, and then we'll go down to 0. And if we reverse going backwards, we fill in a 3 and a 4, and when we look at that graph, everything lines up really nicely. So this is technically grade 10. You don't need to know slope-intercept form, but you do have to graph this table of values for me in grade 9. I'm fine if you want to use a little bit of cheating. You still have to have 2 negative values, you still have to have 2 positive values, and I would like you to have 0 as well. And the reason for that is when you put in 0, that one's simple because we get our constant left over, and that's what we call the y-intercept. When you are picking your values for your x, pick smart values. If you've got a denominator in your fraction, make sure you use that denominator. And what the number in front of x is telling you is that is your slope, which is always how far up or down you move compared to how far left or right you move. And even if we go back where it is just a nice whole number, this one here, it still is or can be written as a fraction. 3 is the same thing as 3/1, and so this slope still tells us 3 spaces up when we move 1 space to the right. And that's how you can use slope and the y-intercept to very quickly and easily graph your line.